Hi, in this video we'll go through the config file maker. The config file maker is used to create the config file, which is what the BMC library uses to determine what features are going to be used. For example, how many buttons, what pin is assigned to each button, to each LED, how many MIDI ports are available, all this kind of thing. Let's give it a quick try. The first thing you need to do is go into the BMC website to access the editor. The link will be in the description below. Once you enter the app, you will see the config file maker button here. We'll click on it. Now, if you already have a config file maker, you can import it. Well, actually a config file that you created before, you can easily import it right here, and all the data will be loaded so you can go in and edit anything. The config file can be edited manually if you want to, but it's easier to use the editor if you don't know what you're doing. The first step is going to be to select the board. In this case, we're going to go with a 3.6. The reason why there's a board selection here is because this tells the config file maker how many pins are available, which ones are PWM, which ones can be used for analog, for pots, and so on. So that's the main reason we're going to do this here. The information shows up down here. Make sure that you specify the board that you're using so that everything works properly. The next selection is the MIDI program change and control change tracking. BMC is going to create an object that's stored in RAM. This object will hold the current program change and current control change value for each of the 128 control changes, and that is for all channels. Now, normally this feature you don't have to really change unless you're using a board like the Teensy LC or you're using hardware that requires a lot of RAM. The reason for that is that if you select 16 channels, that's going to take up 2 kilobytes of RAM, as BMC is going to keep track of any incoming program changes and any outgoing program changes, and the same thing with control changes. This is used by BMC to turn on LEDs, also to do things like toggling a control change. So let's say that you send out control change 10 on channel 1 with a value 0, and you want to toggle it to 127 to turn on and off, I don't know, a guitar effect on one of your devices. BMC will know that you're in control 0, that you're in value, the value for that control change is 0, and then next time you press a control toggle, it will toggle it to 127. Then BMC will know that you're on 127, press the button again, and it'll bring it back to 0, and so on. The option is available here in case, like I said, you need RAM for other purposes. The minimum is 1 channel. If you select 1 channel, that means the BMC will only track channel 1. And as you go and increase the number of channels, it will be for those channels. So for example, if you select 4 channels, then BMC will track channel 1, 2, 3, and 4. You go up to 5, it'll also include 1, 2, 3, 4, and 5, and so on. So normally you can leave this at 16 channels. The system exclusive ID is used in the MIDI standard as a manufacturer ID. BMC doesn't have a manufacturer ID yet, but eventually I'm going to, my goal is to get one. For the time being, we'll use 125 on all 3 bytes, as 125 is the R&D system exclusive ID or manufacturer ID. Once that day comes when I'm able to purchase a system exclusive ID for BMC, then all BMC builds can use that ID. Let's go to the next page. Compile features. This is where we'll choose what features we want available that use up some RAM. First of all, storage method. This is actually a very important part of BMC. This tells the library where to store all the editable data. This is the data that's edited through the editor app. You have 3 options in this case because we selected a Teensy 3.6, and the Teensy 3.6 has a built-in micro SD card. The LC, the 3.2, will not have the built-in micro SD card reader option because they don't have a built-in micro SD card, and I did not want to write code for an external or to support an external SD card. For those who want to use an external EEPROM, you do have the option to use the 24LC256, which is an external I2C EEPROM with 232 kilobytes. So in this case, we're going to use the internal, which is only 4 kilobytes. That the size of the EEPROM determines how big your build can be as far as editable data. That is how many buttons you can have, how many LEDs, how many pages, how many presets, how many library messages, and so on. For a large build, I will definitely recommend that you use a board with a micro SD card, or you could also use an external EEPROM chip like the 24LC256. But we're gonna set it up to internal EEPROM in this case. Debug, this option just tells the editor whether you want the debug information printed into the serial monitor. BMC is going to print and give you a little terminal style serial monitor where you can type in the word help to see all the commands, and BMC can give you feedback on what's going on. You can turn this feature off once you're done debugging or developing your controller, once you're ready to use it live. Fast mode is a feature that will be removed. This is just an extra check that happens during development to make sure that everything's properly done, and this happens at runtime as the program runs. So this will be removed and will be part of debug, and when debug is on, those checks will be performed. When debug is off, those checks will not be performed anymore. That way you know if there's anything that was not set up properly during debug. You will see all that stuff in the serial monitor. Time. This is a feature that uses the time library on Teensy. You will need to use a battery for the time, and you'll have to look into that on the pjrc.com website. This is so the BMC keeps track of the time for you, and you can update the time also through the editor. If you're planning on having a display where you want to show what time it is, then you want to set this option to yes. BMC has an API that will give you the time, and you have callbacks as well for that. This is great if you are doing live shows and you need to keep track of time to know the number of sets, and you have a display on your build. In my case, I have a couple of builds that have displays, and I like to see what time it is. I don't like looking at my watch in the middle of a show. That way I can keep track of how many songs we have to play and so on. BMC also has a stopwatch that's built in that you can use for that, and that stopwatch is actually something I use a lot to keep track of how many minutes are left in the set. I usually start the stopwatch at 45 minutes, and then once we reach 0, I know that the set is over and we can take a break. Line 6, Helix Sync. This one, actually it's not scene, it's snapshot sync. That's a typo, I'll fix later. This just tells BMC to keep track of the snapshot on your Helix device. There's no actual syncing with the Line 6 Helix at all, but in my case I use a Helix stomp, and what I do is I can set a button to scroll through all 3 Helix snapshots and an LED to turn on based on that snapshot. You can do this also just with simple control changes, but this is just a little added feature that I wanted to have to make it easier and simpler, I guess, to select the snapshot on my Helix from my BMC build. Beatbody sync. BMC actually will sync with your Beatbody. There's a couple of things that you need to do. The information is there when you click on the question mark, especially once you go into the editor. You will see events on your buttons. This is, for example, for you to select a part on your beat body, for you to start, stop, all those things. That's all built into BMC. You have to follow the instructions. I'm going to add those instructions actually here. I believe they're only in the editor at the moment, so this is a great feature if you have a beat body. It will make life a lot easier. Fractal Sync. If you own a Fractal AXFX2, AXFX2 XL or XL Plus, or an AX8, you can actually sync BMC with your Fractal and set up LEDs to light up whenever a block is on, off, in X, Y, the scene of your Fractal. You can use it also to control presets and all that good stuff. BMC will actually connect the same way that the editor for the Fractal devices connects to your Fractal hardware. So this is a great feature if you have a Fractal AXFX2 or an AX8. You want to use this feature. It's awesome. The Kemper Sync is not implemented yet, as I don't have a Kemper anymore to do the syncing with or to try that stuff. I left that feature there because I'm planning on getting another one for testing and to make sure that I can sync things like the tuner and whatnot. For the time being, you can't. This is not available. It will not be compiled into BMC. The next three options: exclude I2C pins. If you have a device connected to I2C that's not part of BMC, then you can select this option as yes. What this does is it tells BMC not to give you the option for those pins 18 and 19 on your Teensy, to connect buttons or to connect LEDs and things like that. If you're planning on using an SPI display, then you also want to select this option as yes, so BMC will not use those pins for something else or whatever it is that you want to connect through SPI. In this case, I'm not doing that. The click track is only available for the Teensy 3.2 and 3.6. This uses the audio library, and basically it's just a click track sound that syncs with the master clock or slave clock. That means that when BMC is receiving a clock, BMC will play back a click track for you. It's just a little click, click, click. Very simple, very straightforward. Again, you would have to wire the output into the Teensy's DAC pins. So more information on that will be available later. It's a feature that I don't use as much, but I used it a long time ago when I first started BMC with a Boss RC300, so that I had a separate click. Now let's go to the next page. Ports options. This is where you select how many MIDI ports you want available. BMC will always use the USB MIDI port. However, you can also have up to 4 serial MIDI. That's the 5-pin MIDI connectors. That's input and output. All you have to do here is select which ones you want, what pins are assigned to each one. You can have, in this case, you can do 0 and 1. Those are the pins for receive and transmit. You want to make sure that you look into all this stuff before obviously you use BMC, that you know how to wire a MIDI input and output circuit. It's not just wiring the pins into your Teensy. You will need some circuitry for that. You have up to 4 of them. This is dependent on the board and how many hardware serial ports are available on your board. BMC only uses the hardware serial. It doesn't use software serial because, let's just face it, it's way better. Disable the input. If you only want to use an output jack on your device, you're just sending MIDI messages, then you can set this option to yes. That means that the input will not be read on MIDI. Normally, if you're using a foot controller and you're just sending data to a couple of devices, you don't need to read what's happening on them. You only have buttons, you don't have LEDs or a display to show anything. Then you will only need an output jack. But if you want to do full sync with other devices, then you want to leave this option to no. Same thing goes for all of them. They all have to be different pins. You cannot use the same pins for serial A, B, C, or D at the same time. So make sure that that's understood. The next thing is BLE MIDI. That's Bluetooth LE MIDI. BMC has code to interface with the NRF 8001. Unfortunately, that chip was discontinued by Adafruit. They used to sell a breakout for it, which was amazing. I was using it a lot. Now that it's discontinued, I'm still looking for a replacement for it. This is where you set up the pins that you're going to use. For the time being, we'll skip it. USB MIDI, USB host MIDI, and Pixel ports. So in this case, we're using a 3.6. The 4.0 and the 4.1 also have a USB host. If you select this option to yes, you can actually use the USB host port to read and send MIDI commands. In my case, for example, I have a Fractal AX8, which has a USB port, and that USB port is the only way to send and receive MIDI system exclusive from. So you need that port in order to sync with the AX8. Now in this case, you can set that option to yes to enabled, or just not use it. That's just an additional MIDI port on the Teensys. That's what's so great about them. The next part is pixels. Pixels are NeoPixels, or the WS2812 LEDs. They are addressable. They only require one pin. You can have up to 64 of them all together. And what's great is BMC will actually give you the colors to use. You can change the color per page, per event. So they're awesome if you don't want to have a ton of wires from coming out of your Teensy. You just want one wire for all your LEDs. This will be the option to use. The pixels use the serial WS2812 library from Teensy, so you need a hardware serial pin for these purposes. In this case, you could select 10. This is the transmission order. Some pixels are RGB, some are GRB. That means green, red, and blue. It's just the order of how the data is transmitted to them. You may want to look into how the WS2812s work first before you come into BMC. The enable pin is a pin that can go high or low when BMC launches after it waits a couple of milliseconds. That's in case your pixels light up right away. Some pixels will light up in one color immediately after you power them up. With that pin going high or low, you can have a relay or some sort of transistor circuit that will power them. That way, as soon as they're powered, within a few milliseconds, BMC will send out a blackout to them. Let's go to the next page. Multiplexers. If you check the documentation, you'll see that BMC doesn't just use the pins on your board. BMC can also use multiplexers. In this case, there are 3 types of multiplexers. I have planned to use a 4th type of multiplexer, which will be an input and output. That's a multi-purpose, or in this case a general purpose I/O pin, and those will be using the MCP 23017. Those are I2C devices, and with those you can set every pin on the chip to be either input or output. For now, you can go through these options. If you want to use mux in, which is just input pins, this can be used for buttons or encoders. Since they're digital, they're not analog. Here you select what pin is wired to everything, how many pins you will use from those, and this BMC will do all the work for you. You don't have to worry about anything. All you have to do is wire it properly and you're good to go. The same thing goes for the mux out and for analog mux in. These are just output pins. The 74HC595 is a pretty common chip used for LED control, so if you're planning on using a lot of LEDs, or if you want to build yourself some sort of panel or a custom circuit board that has a multiplexer built in and all your LEDs already wired, and you don't have to wire everything onto your Teensy, then this will be your best bet. You also have that for analog using the 74HC 4067 and 51. These are the 4067 is 16 channels, and the 4051 gives you 8 channels, so 8 pins, 8 analog pins. You can select this as you need it. There'll be a lot more information as we go. The next section, your hardware. Here's where you select how many buttons, encoders, pots, all this good stuff that you're planning on using. If you're using 1 button, then 1 button. You're using 4 buttons, 4 buttons. You want to use an encoder, here's where you select it. This we'll start with just with 1 button for the time being. In addition to that, BMC has page buttons, which means that they are assigned per page. That means that when you change pages, that button will change and have completely new data assigned to it. That means that your board will become, all the buttons that are page buttons will become completely reassignable as you change pages. In addition to that, you have global buttons, for example, which they never change the role. The role is always the same. This is useful if you want to have a button that changes pages. For example, if you want to always use that button just for pages, then you might as well just use a global button. The reason for that is that that'll use a lot less of your EEPROM, as each button uses a certain amount of EEPROM. Then on top of that, each page and each button will use more EEPROM. So if you just want a button to do something all the time that's not going to change as you change pages, then you want to create a global button. Same thing goes for encoders, pots, and global LEDs as well. Relays in BMC are also global. They're not on a per page basis, so they always have the same role. Another feature here is the pot's toe switch. If you want to use this feature, you have to enable it. BMC has the ability to do an auto engage, so this is great for expression pedals. If you want to have an expression pedal that engages and sends a control change to your device to turn on, let's say, a wah effect as you start rotating the pot, then BMC will do that. And once you return the expression pedal to its heel position, the off message can be sent. This is also useful if you want to simulate an expression pedal that has a toe switch like a wah pedal. If you're familiar with analog wah for guitar, then you'll know that they have a foot switch in the toe position. So you'll have to dive in a little bit, and if you want to try this feature, just select it and you'll see it on the editor. I'll show you a little bit more about that when we go through the editor. The device name, this is the name that's passed to the editor that will be displayed on your screen. This is also used to store local settings for your device. So for example, if you have, I don't know, like a guitar processor, or let's say a Fractal AX8 connected to channel 1, you can give that channel a nickname, but that data is not actually stored in EEPROM because it's a little bit of a waste of space. Instead, that data is stored by the editor itself in its local data, and this device name is what BMC will use for that. Additionally, you can give your Teensy MIDI a custom name. Normally, when you compile a Teensy with MIDI, with USB MIDI, the name for that device when it's displayed on your computer will be Teensy MIDI. So you can actually change that name right here and call it whatever you want. The default is Teensy MIDI, but you can call it whatever you want. Basically, that way you know which MIDI port on your computer belongs to your device. Let's go next. In this page, you will be presented with a selection of the pins for each piece of hardware. For example, in this case, we only did a button, but if you have LEDs and things like that, you will select what pin is assigned to those. In this case, actually, let's go back and let's add an LED so you can see what with a global LED. So here's the button. We select the pin. For the LED also we have to select the pin. It has to be different. If you use the same one, you'll get an error from the editor, which is fine. It's pretty straightforward. But what's cool too is you can select what's the color of the LED on your build. So let's say that you're using all green LEDs, you can just make them all green. So when the editor displays them, they will be displayed in green. BMC has feedback from on the editor, so that means that when an LED lights up, the LED on the editor will also light up. So if you want it to be the same color, then this is where you will select them. Actually, in this case, we'll select 13, which is the built-in LED, and that built-in LED is orange in Teensy boards, so we'll go with that. That means that when this LED lights up on the editor, it will always be orange. The additional build options, this is where you select the number of button events. If you have buttons, you can select up to 8 at the moment. I may expand that later on. So the events on the buttons are basically when you press that button, how many things you want to happen. Let's say you want to send a control change, you also want to send a program change, you also want to change pages, you also want to send a note on, a note off, and so on. This is where you select, those are your events. This is where you select how many of those are available. So with every press of the button, you can send up to 8 actions. Every one of them also can have its own trigger, which means that they can be assigned to press, to release, hold, double press, continuous, and so on. And they're each independent. So that means you can have 2 events that are for press, 1 event for hold, 1 event for release, and so on. In this case, we'll leave it at 1. Pages, that's how many pages BMC will have. As I mentioned, buttons, LEDs, pods, and pixels are all within pages. That means that if you change a page, you'll have a completely new layout or a completely new set of controls assigned to each one of those elements. So on page 1, all your buttons can be assigned to program changes. On page 2, they can all be set up to control changes. On page 3, it can be a combination of control and program. On page 4, they can all be used for I don't know, to control an external device or a display or a menu of some sort. So this is where you select how many pages you want. There is a maximum of 255, but what you want to keep in mind is that each element that you have on your build uses EEPROM, and because of that, the more pages you have, the more EEPROM you'll use. In this case, you can also see up here, you'll see how many bytes you're using right now. In this case, we're only using 74 bytes at the moment. We'll go to 8 pages, and this will use a lot more, except right now it's not showing because we haven't set up everything else in here. So we'll continue with that. We'll leave it with actually 4 pages. Page names, this is where you specify if you want to name your pages. You can assign whatever number of characters, up to 31 characters plus a blank, a zero, an end of line, or an end of string. You can select whatever value you want. If you select it, just keep in mind that when you select 8, that means that every page is going to use an additional 8 bytes of EEPROM space. The same thing goes for buttons. This is for buttons, for page buttons, and for global buttons. For LEDs, when you select an LED name, that will be for LEDs, global LEDs, PWM LEDs, for pixels and RGB pixels. Encoders and pods, same thing. Relays, the same thing. The library is basically a library of MIDI messages that you can save. Those library messages can be sent out as part of button presses. So let's say that you want to have, that control change 10 is always going to be your reverb. So you can save it as a library event. And let's say that for whatever reason you change that control change on your hardware, on your guitar processor, then you can change it also on the library, and it will not affect any button that is assigned to that library item. These are basically predefined MIDI messages that you can reuse however you want. You can also name them. Actually, you have, before we forget, we have up to 255 of them. You can also name them the same way as before. The string library is basically that, a library of strings. You can use this. Basically, it's meant to give you the option to edit a list of strings, and then you can pull those up with the API. Let's say that you're controlling a device that has whatever presets, and those presets don't have the names are not being synced into your BMC device. So what you can do is select, let's say that device has 16 presets. You select here that you want 16 library strings or string libraries, and what that means is you'll have 16 strings that you can name. And as you change presets on your device, you can set up BMC through the API to display that string on your LCD or an OLED or whatever you're using. Here's where you select how many characters each string will use. Just again, keep in mind all of this takes up room in EEPROM. Presets. In BMC, presets are basically just a collection of library items or library events. That means that one preset can send out, let's say, 8 different library messages. So let's say that you want to press preset 1 and you want that preset 1 to send a program change to one device, send a control change to another device, and so on. You do that here through presets. Here you can select how many you want, how many library events per preset, in this case up to 16. Presets per bank, that's for BMC to do banking. We'll go over that later on. Preset names, you can name your presets or select no. Just again, all of this takes up room in EEPROM. Set list, BMC can give you a set list. Each set list has songs, and each song is a preset. So each one of these contains these, and these are basically the same thing as these up here. So you can select the number of set lists that you want. Each set list can have this number of songs, and each song is a preset. You can have 32 songs per set list. You can also easily rearrange the order through the editor or the API. You can also give your set lists names, so it could be set number 1, set number 2 slow, whatever. Custom sysex, BMC can give you up to 16 bytes for a system exclusive message that is sent out. That's without including the F0 and the F7 bytes that are required for system exclusive. Here these are all editable, so you can create custom system exclusive messages. You can select how many you want here. You can send those out as part of as library events or as part of buttons, and they're great if you want to send a specific command to a device that doesn't respond to control change or program changes. Triggers, these are MIDI triggers. Basically, VMC can be told that if it receives program 1 on channel 0, that you want it to do something or to tell your sketch something. So it's always listening for MIDI messages, and if that MIDI message matches the one that you set up through the editor, BMC will perform your action of choice. In addition to that, you can also use triggers for translation to change the channel of the messages. So if you receive program 1, you want to send program 10, or you want BMC to think that it was program 10. So it's a lot of good stuff that you can do with this. Also with triggers, for example, an external MIDI controller can send a control change to BMC, and that control change will tell BMC that a button was pressed, to emulate a button press on one of your buttons, or to turn on an LED or blink an LED. So it's very powerful, and we'll dive into that later as we go into each specific feature on BMC. Tempo to tap, that's a feature that I use to send out control changes in intervals. A lot of devices will have a control change option, and that control change parameter will act as a tap tempo. Okay, that means that if you can send it from an external MIDI controller. You can tap a button that sends, let's say, control change 10, and then your device will get that control change and analyze the time between taps, between those messages, and use that as the tempo for a clock, for a delay, that kind of thing. So this feature allows you to use the master clock or the slave clock, and as that clock changes, BMC will send four control change messages that you specify in that interval to simulate a tap tempo. And it's usually a control change that you want to do that with. We'll get into that later. Sketch bytes, those are actually basically just an array of bytes that you can edit through the editor, and then BMC can read later. You can read them through your sketch. Those are, I use them, for example, to set the brightness of a display. In my case, let's say I have a Nextion, I can use a sketch byte to, through the editor, easily change the brightness of my Nextion display. This can be accessed through the API. In addition to that, there's formatting. So for example, let's say that, again, this is a display, this is the brightness. The initial value is going to be the minimum value, and here's the minimum and maximum. Let's say that you don't want the brightness to be 0 because that'll turn it off completely. So we'll, and you have a range of, I don't know, let's say 0 to 10, where 0 is completely off, 1 is the dimmest brightness, and 10 is the brightest for that display. So you can set it here to 0 to 1. And the initial value, when BMC first creates the store and builds a structure for your data, the initial value for that will be 1. That way the display is never off. And here you can set the maximum. In this case we said that it was 0 to 10, so we'll set it to 1 to 10. The steps, 1 to 10, you can change how many steps. If your display you want to only have like a couple of steps in between, you can set it to 2, and then that means the BMC will go from 1 to 3 to 5 and so on. This is a display this is how the data will be displayed for the editor. Display row will just show you the actual value on BMC. You can also add a value. Let's say that this is all indexed by 0. So let's say that you want, it's going to be 0 to 9, but you want to display it as 1 to 10. So this is all used for that. We'll actually get into that a little later in the, once we dive into the sketch bytes on the editor. Value, this is how much you're gonna add to it. In this case, we selected add value. We can add 1. So instead, like I said, it's the editor will display 1 through 10, or you can make it add 6, and that means that it's gonna display 6 through 15, 14, whatever it is. Let's leave it at 0. Append, you can append to that value. If this is something that's going to control timing, you can make it seconds, milliseconds, and your sketch will handle whatever you need done. What did we miss that? Oh, we didn't add we put a string library, but we never added the number of characters, so we'll go back to 0 since we're not going to actually use it. Okay, so now in this screen you can arrange your hardware, your buttons. You want to do this based on what your device actually looks like. In my case, if I have 4 buttons and my device has, the box that I built has button here, a button here, a button here, a button here, then I will lay them out in those positions just so that they look exactly like my device. That way it's easy to recognize where things are. Okay, very simple. You can actually double click on a button or any of these items and position them. That's what you want, or revert. If you're done, once you've done this stuff, just hit done and you're good to go. This is where you'll arrange all your hardware: buttons, LEDs, encoders, pots, and so on. Next, now we're at the end. This is where you'll be presented what your config file looks like. This is the data that's actually used by BMC. On this side you'll see a much larger file, and that's because BMC will include a JSON object. That's a JavaScript notation object, and that's the data that's used by the editor when you import your config file into the config file maker. So you can see here this brackets that represents the JSON object. However, the actual library only uses data from here on. You want to leave this file as is. You can either click in here and select all and copy it and make your own config file, or you can just save your config file. Unfortunately, because we're using Chrome will either ask you where to download it to, or will immediately download it into your downloads folder. So in this case, I believe I have it set up to just download, so my config file was just saved. Now if we go to downloads, here's my config file. Very cool. Download it again, and we're good to go. So that is our little config file maker video. I hope this helps, and I'll work on some more videos for you as time comes. Next, I'm going to try to dive into each feature independently. That way we'll come back to the config file, and we'll go to the actual editor where you can see each feature up close and how it works and how to actually use it through the editor. As you see those features in use through the editor, you'll have better understanding of whether you need to use them on the config file maker or not. Again, BMC is a very complex library, does a lot, and it's going to require a ton of documentation. If you want to help with things, please go to rockstar.com and shoot me an email, and I'll do my best to continue with this, and hopefully this will help you, and happy building.